Good evening, and welcome to the General Society of Mechanics and Tradesmen. I am Karen Taylor. I am the program director. And I don't know if you all realize, but this piano has been playing by itself. This program is supported in part by public funds from the New York City Department of Cultural Affairs in partnership with the City Council. I also want to express our thanks this evening to Steinway Sons, especially to Jennifer Charamonte and Dan Miceli, who made this evening possible, and to Thomas Donahue, who has created a special window display in honor of this event. The General Society was founded in 1785 by the skilled craftsmen of New York City, artisans who represented 22 different trades. This include carpenters, blacksmiths, silversmiths, tailors, among many others. Today, our 233-year-old organization continues to serve the people of the city of New York through its educational and cultural programs. These include our tuition-free Mechanics Institute, our Lock Museum, which is upstairs, and you are welcome to visit it after tonight's program. The General Society Library, of course, which you're in this evening, and our nearly 200-century-old lecture series, of course, of which this artisan lecture is part of. You will find additional information on a blue and white postcard on the front registration table, and indeed on library membership. Master to apprentice, generation after generation, each Steinway piano is built with experience decades in the making by artisans who take pride and time to humanize a piano still made by hand, who strive for and achieve continuous innovation and improvement. Every Steinway piano is a work of art consisting of more than 12,000 individual parts and has its own musical character. And tonight, we are so fortunate to have this opportunity to focus on the iconic Steinway piano. And to talk about the craftsmanship and restoration of Steinway pianos, we are delighted to have Bill Youse, the Director of Technical Services and Special Projects at Steinway Sons. For the past 45 years, and by the way, I think as Bill may tell you himself, he's part of like 4 generations who've been employed at Steinway. Bill has worked in nearly every job in the Steinway factory. He is a 3rd-generation Steinway craftsman, having followed in the footsteps of his father and his grandfather. Mr. Youse started at Steinway in 1973, first taking on routine facilities maintenance and then moving up through packing and driving before being recognized for his initiative and placed on the bench, learning the highly skilled piano craft work for which Steinway is known. He worked in the color matching and action departments before being selected for an apprenticeship that taught him so much about every aspect of piano construction process that he was highly suited for his next gig, which was to be a restoration specialist. He has also directed Steinway's restoration services, where he has overseen rehabilitation of some of the most famous pianos in the company's history. It is now my huge pleasure to introduce to you Bill Youse.
Good evening, everybody. Thank you for coming tonight. I'm here to tell you a little bit about, well, let's talk about the company a little bit first. Not quite the history of the organization here. We've been around since 1853, 163, 4 years around. So we've been here for a little while, always in New York. And we are still making pianos here in Queens. So it's again, a New York company. A little bit about me, you've heard a little bit about that. I am 3rd generation at Steinway, 3rd of 4. My son is there now, still working. My family now, on July 2nd of this year, I will be at Steinway 45 years. Very proud of that, quite frankly. And my family, thank you. My family has a little bit over 120 years of history with Steinway, so again, I'm very proud to be part of this historic organization and to be with you here tonight. So we're going to talk a little bit about some of the secrets of Steinway. Obviously not all of them. We'll keep some of that to ourselves a little bit. But let's start moving a little bit through the program. Okay. This is, again, to teach you a little bit about what goes into a Steinway, what we do to make Steinway the standard piano of the world. And as the standard piano of the world, if you ever hear people comparing pianos out there, it's always compared to a Steinway. And that's basically what that means. It is the piano that all other pianos are judged against. And there are reasons for that, and we'll talk a little bit again tonight about that. There are four, I heard some of the trades that are involved in the organization, blacksmiths and things like that. We don't have all of those anymore, but we do have some major, what we call disciplines of craftsmanship, and some of them are up here tonight. Case, belly, action, and finish. These are some of the main areas of expertise that go into building a piano, and every single one of them has their own special craft and their own special details, and every single one of them has to be right for the piano to be what we want it to be at the end of the day. The Steinway Fortress. We look at it as the fortress because the piano is built so sturdily and everything that goes into it is protected by the outside of the piano, the case. So we call that the Steinway Fortress. Now you'll see at the bottom there, it says the case or rim of the Steinway grand piano is the foundation on which we construct our pianos. Absolutely. If anybody here is any kind of crafts at all, you know the foundation is the most important part of any building. The foundation is weak, the building is weak. Foundation of the piano is weak, so is the piano. So the rim and the case of the piano is built way above what it really needs to be in order to control the piano. And as it goes through the factory, the piano takes on different names. At the end of the day, it's a piano. But when it starts out, it's what we call laminations. It literally starts out as laminations of wood. When we compile those laminations into whatever specific model the piano is going to be, Model S being the smallest and the Concert Grand, the Model D being the largest, we put those together, and that's called a book. When that book goes down to what we call the rim press, is what you see here, it then becomes a rim. As it moves through the piano, through the factory a little further, it becomes what we call a case, and then eventually finally a piano. So we're going to follow some of that tonight, how it moves through the factory and takes on the different names. Here's the beginning. These are the laminations. These are rock maple. They come from the northwest of the United States, Oregon, Washington, up in Canada a little bit. But this is the hardest wood that you can literally use to construct a piano. This wood is so hard you could not drive a nail through that without drilling a hole through it first. It is extremely, extremely hard and extremely stable, and it's the reason we use it. And what we will do is we will gather the laminations together for, again, the specific model and the specific size, and it'll move down to our rim bending press that you saw on the earlier slide, and literally manhandled around a form. These are called rim presses. We are still using the original rim presses. We started pressing pianos like this in 1876. They are still the original forms. They have been restored, they have been upkept, and so on, but they are the originals. And this is still done by hand today. It's literally manhandled and tightened into this press. This is a little bit of the process. This is one of the gentlemen using the wrench to do that. Now again, there is no steam used here. There's no heat, this is strictly manhandling and forcing this piano around this form. We want this piano to be, quite frankly, under stress. Pianos work best under stress. When strings are stressed against the soundboard, when strings are pulled and stressed out, this is what gives a piano its power. This is one of the rims coming out now. But what I want you to notice, see if we can use this little gizmo here. Okay, this little line that you see going around the bottom side of the piano. We are one of the only, there's only one other that I'm aware of, and it's a very small boutique piano company that presses their rim in one pressing, which the inner rim, which is the smaller rim down here, that takes on the soundboard, the harp, the cast iron plate, the strings, the tension of the piano, is pressed with the outside, the furniture. Every other manufacturer, except for one that, again, that I'm aware of, does this in 2 parts. Much easier. You don't have furniture to deal with. You don't have to get inside the piano. You bend this inner rim, you put a soundboard on it and strings, and it literally moves along a conveyor belt. One guy will do a tuning, one guy will do a little more work, and so on and so forth, and it moves throughout the factory that way. Our pianos, quite frankly, are what they're going to be. Another thing with these inner and outer rims, when the piano is just about done, if you walked in tomorrow and said, well, I want a pink piano, they'll grab a pink outer rim, and they'll put it around the inside of the piano and make you a pink piano. If you wanted any other color, any other veneer, whatever, it's that simple. They go out, they get the furniture part, they slap the furniture around this inner rim, and there you go, whatever color it was you particularly wanted. With a Steinway, that piano is what it's going to be 2 years before it's ever made. Our marketing people will tell us we want X amount of, let's go with pink again, we want X amount of pink grands. We've only done one that I'm aware of, by the way. They will tell us, okay, factory, you're going to make X amount of walnut concert grands and X amount, and that piano, again, is planned 2 years ahead of time. Once we start that piano, that's what that piano will always be. So we have to be very careful and make sure that everything is exactly right, because that's what that piano is going to be. There's no going back and there's no changing it. Now again, this is what you see along the side here. When a piano gets bent around that rim, it has to condition, it has to cure, it has to settle. One thing I've noticed, and I've traveled around a little bit to other piano manufacturers in Asia and so on, the one thing that they don't get is conditioning, seasoning, and what we call dwell time. In between operations, things need to settle. They need to reach their equilibrium. A lot of places force things through. Give you a quick example. At Steinway's peak, if we're producing as many pianos as that factory can produce, we may produce about 3,000 pianos in a year. I won't make generic names, but there's an Asian company that did 250,000 a year when at the peak of the piano industry. Things have gotten down a little bit more. They don't do that quite anymore. But they actually can produce that many pianos. The most Steinway could ever produce, my father used to tell me, we'll never get more than 3,000 pianos out of that factory. Because that's what it takes, the time and the dwell time and the conditioning to get a piano to what Steinway believes it should be. Now, the rim itself, you'll see down over here, these are those laminations. These are those inner and outer rims. On a concert grand, there'll be 18 laminations thick because of the extra tension. Down the smaller pianos, it goes down to 11 laminations. But that's a slightly thinner piano. Matter of fact, this piano here would have 11 laminations on it. But the concert grand, 18. It is, like I said, rock maple. It is flat sawed, hard rock maple is literally the name of the wood. They are hand assembled. Again, we saw the presses, and it's literally done by hand. There are, again, companies, everything is pneumatic now. They push a button, and the presses come up, and it squeezes the rim against some shape. But everything at Steinway is still done by hand. These gentlemen have to understand how much pressure, how much tension, how tight does that clamp have to be, in what succession do those clamps have to be tightened. It is probably the most coordinated and choreographed part of what Steinway does, because there are 6 or 8 guys working in concert, and each one has to, if you ever go down there, there's no talking. Nobody talks. Quite frankly, some of the guys can't even understand each other. But they do know the body language, and they do know the process. So when they see somebody move and they see somebody, they know that that's what got to happen. So they all follow in concert, and again, to watch it is pretty incredible. As a matter of fact, and it has gone so unchanged over the years that we have, well, back before when they came in as talkies, well, before that movies were silent, we have silent movies of gentlemen tightening up those presses, and as they're pulling it out, we switch over to one that was done last week, and you almost can't tell the difference other than one's in color and one's in black and white. It is the same operation, and it's done the same way that it's been done since 1876. Again, single rim bending, strategically placed dowel, you'll see this in a minute. Now we've come from a rim. We've taken the rim out, and what you saw here is a conditioning room. Those pianos will sit in there for a bare minimum of 6 weeks. The reason they have to be in there is because when we glued the piano up, we introduced moisture. We've got to get back to the proper moisture content, so the piano will sit in a conditioning room, heated with the proper humidity levels, and the piano will dry. We want that piano to settle. We don't want it to move later when we start adding parts on it. We don't want that piano to flex and to start drying and to move and to change its dimensions. So we have to make sure that it's completely cured and dried. And again, throughout the factory, another quick kind of comment. People always ask, how long does it take to make a Steinway? Well, a standard piano takes a year. Within that year, there are only 350, literally what we call man-hours of labor put into that piano. The rest of that time is conditioning, drying, and settling, again, what we call dwell times. And we will not compromise those dwell times. For instance, tuning. Yeah, it has to be 1 day, 24 hours between tunings. Could you do 3 a day? 4, sure, absolutely. But the tunings won't hold. So we literally have to wait 24, and we will not tune that piano until that 24 hours is up. The time that piano was tuned the first time is logged in, and there's a card that goes with each piano, and we will not touch that piano until that 24 hours of dwell time between tunings has expired. So very, very important, and we follow every one of those things. Again, we're reaching now, the piano was a rim. Remember I told you the different names it took? First lamination, then it'll be a rim. Now it's going into the area where it'll be a case. And case construction is where we start to add the structural elements in this piano. These are the things that are going to hold up with, when you tune a piano to A440, and I'm sure most of you know what that is, when you tune a piano to A440, there are 40,000 pounds of pressure trying to suck that piano in on itself. That's 20 tons. So to fight that, we have to make sure, if that piano couldn't hold up against that, it wouldn't maintain tuning, it wouldn't maintain its tone or volume. So we have to make sure that it's going to be stable enough that when we reach those kind of pressures, the piano is going to hold. So the things that go into play now are part of that. And these are those radial braces that you see being added. Again, they are glued and doweled. We don't screw those things in. There's no screws and nails. These are wooden dowels like they used to use back in the early 1800s. We still do it that way, and it's still the only way we'll do it. So these gentlemen are adding the radial braces, and you'll notice that they kind of radiate out to, which is why we call them radial braces, but they radiate out along the perimeter of the piano, so that is holding again against the pressure of those strings. This is just another example. The smaller pianos, the radial bracing is, again, strategically placed so that when you add that pressure to the piano, it's going to maintain itself. The benefits of that, stability. Without stability, tunings won't hold. And what good is a piano that can't stay in tune? It's like a car that can't keep air in the tires. You can't use it. So it has to be stable. Longevity. Part of what I do at Steinway is I oversee the restoration of older pianos. And the average age of pianos that I restore is 75 years old. So longevity is important. If you were to buy a piano, and pianos are not inexpensive, they're not cheap. So if you were to buy a piano, you want that piano to last. And again, the pianos that I restore are the average age is 75, and I've had them come in. I've got pianos there from the Civil War that still played, that still, they were lacking a little bit, but they held up. The idea is when you make an investment in a Steinway, this is something that should last not only for yourself, but for generations of your family. And I cannot tell you how many times I've had people come in, oh, I just want to restore grandma's piano. Because, look, our business is to make new pianos, right? So some of the guys in management aren't really wild about restoration. You know, hey, how are we going to sell new pianos if you guys are rebuilding all the old ones, you know? And we've proven over time, the pianos that I get are not because somebody wanted to save money, and because it's not a cheap process either. It's not to save money, not so I don't have to buy a new one. They want grandma's piano back. They want the piano they learned on when they were little. They want the piano they used to hear Aunt Ethel play back in the day. And I have an Aunt Ethel, by the way. But when they used to hear, you know, so these are very emotional involvements when they restore a piano. So we've proven over time, and I begrudgingly got from management, okay, and even from some of our retail people that, okay, look, there is a customer that just wants that old piano back. So we want them to be around for a long time. We want them to go to the next generation. We want, and quite frankly, look, that generation's going to take it and say, hey, you know, this is a really good piano. You know, Grandma had it, Mom had it, now I have it. Well, if they ever think about buying new, we hope that they think about buying a Steinway. And projection of tone. If there is not a stable base, if this thing is not structurally strong, the tone just dies off. The piano doesn't have the strength to hold up against all those tensions, and you get very weak tone, very weak carry, and very weak volume. So, and again, we've been around long enough and have had our pianos come back that we know that we're doing the right thing here. Now we're moving on a little bit further now to this case to add some strength to it, but more importantly, again, tuning stability. The pin block that Steinway has is patented by Steinway. It's called the Hexagram Pin Block, and I will admit to you that I don't know why, because it only has 7 laminations. So why it's called a Hexagram Pin Block, I don't know, but somebody somewhere said this is a good name. But it works well. It is 7 laminations of, again, rock maple. Each lamination is in a different orientation from the one before it. What that does is, if you happen to have an extremely dry period, all of those laminations would react the same. If they were all going in the same direction, they would get loose on a dry day, they would get tight on a hot and humid day, and your tunings would be completely unstable. So we have found that this Hexagram Pin Block actually does. We actually have people that come to us to buy these pin blocks from us to put in other pianos, because the tunings are more stable, the tunings are more smooth, tuners like them better, and they hold better. Unfortunately for them, we don't sell them to anybody else, but they are considered the best pin blocks in the world. They are blind doweled into the rim. That means that these things are doweled into the perimeter of the piano. You will never see it, and it happens during the assembly of the piano. And it's called blind doweling because it goes inside, and we make specialized jigs to show us where the dowels have to go, so that when we put the piano together, not only is it tuned well, it helps to hold the piano together as well. This is Cortisone Maple. The other one you saw was flat sawn. Flat sawn is good for plots that you're going to have supported when you glue them together like that and you put them in a press. The pin block is going to be out on its own. Cortisone is a little more stable. It doesn't react as much to weather and things like that, so that's used in a pin block. And again, that doweling process is done by hand. There's no machines that come in there and tell you where to put it. It's literally guys making marks and jigs, and they do it that way. Again, tuning stability. The laminations going in opposite directions like that give us that tuning stability. And I'll say it again, what good is a piano that doesn't stay in tune? Longevity, again, through the time that we've been restoring pianos, we know that these pin blocks last, and they do. And savings over time, because you don't have to tune the pianos often. It holds that tuning well enough that twice a year should be sufficient. I know people that tune once a month. I've tuned in my life, and I've had customers where I've tuned once a month because the piano just doesn't hold it. Steinway is very, very, very rarely, unless they're completely abused, does that ever happen. Okay. Now we've talked about the case and the rim and things like that. We're getting into now the technical aspect of the piano, the belly. Now, the belly, some people call it the soul of the piano. I happen to agree. I call the action the heart, and the soundboard and the strings the soul. The action gives you makes the noise, makes the music, hits the strings. But the soundboard allows the strings to vibrate. It gives you volume. If it's done properly, it gives you color, it gives you carry. So the soundboard is an extremely important part of that piano. And quite frankly, one of the very few things that if it's done improperly, nothing you can do. You've got to tear the whole piano apart and do it all over again. Action, you can change some parts, you can move things around a little bit, but the soundboard is glued in. That is again the soul of the piano, and if it's not done exactly right, it's just not gonna. You're just not gonna have a decent piano. So extremely important part of the piano. You saw the 4 what we call disciplines in the beginning. And any one of the guys in that factory, if you go to them and you said to them, what's the most important part of this piano? Every single one of them will tell you the same thing. Mind. And that's exactly what we want. It's exactly what we want. Every aspect of that piano has to be perfect, and everybody that's doing it needs to feel that theirs is the most important job, because it is. Every aspect of that piano is important. When you look at a piano like this, you should look everywhere and enjoy what you're seeing. You should sit down and enjoy what you're feeling, and you should enjoy what you're hearing. So yes, everything that everybody does there is important, even the guys that put the piano in the box to ship it. Because quite frankly, if they don't do that right, when you take it out at the other end, oh, my poor Steinway's damaged, or it's scratched, or it's not. Every bit of it is important, every single bit of it. Start with the plate. Yes, ma'am. Oh, please, and by the way, I'll get you in just a second. If you see something or say, please, don't hesitate to ask. We're going to have questions and answers at the end, but if you see something here you might not remember later on, because that does happen, feel free to ask. I have no problem answering questions. Yes, ma'am. The Hexagram Pin Block? Yeah. Okay. Right here, I'll talk loud as I can. Right here are the tuning pins. Okay? That's the Hexagram Pin Block. Literally runs. Okay. Gotcha. Okay. Okay, here we go. Okay, so the pin block runs literally right through here. And these tuning pins are all installed into that pin block. It's underneath the harp and just above the action. In this piano here, it's literally right across here. Right across there. And it is attached at both sides to the rim itself, that inner rim that I showed you before. And yeah, so that's where the pin block is. I'm going to go back a second. Again, the harp is that entire piece that you see, all of this brass here. Some people on the outside call it a harp. We call it a plate. So you may see it called either one there. In the factory, we call it a plate. A lot of people on the outside call it a harp, but it's the same, basically the same thing. It is what we call a double cupola design. Now, this was done by the Steinways, and one of the reasons that it came about was Steinway actually, when pianos were first made, for those of you who are familiar with the inside of a piano, you notice that the strings kind of cross over each other. The bass strings cross over the steel strings. That's called overstrung. When pianos were first designed and first built, they were straight. They didn't cross over the other ones. Piano had to be bigger. So to get the same sound, the same length strings, you had a piano that was 6, 8, 10 inches longer. By passing the bass strings over the treble strings, you were able to get the piano shorter. You actually had a wider soundboard, so that gave you more sound. But we got a secondary benefit from that, because to allow that to happen, you had to raise the plate, because the strings are now going over the other strings. So you had to raise the plate. And what that did was, I'll see if we can find a... Okay, this is a good spot here. If you notice, there's a flange around the outside, and then the plate raises right around there. That's the first cupola. And a cupola is basically a dome. And what that dome is it gives us a resonance chamber. So when the soundboard starts to move, it resonates better inside that dome, and it makes a better sound. When the bass strings passed over the treble strings, we raised it up in the back. That gave us a second one. So now we had a second cupola. We had a second resonance chamber, which actually improved the tone of the piano as well. So again, invented by the Steinways. The Steinways actually had 135 patents for the piano itself. Way more than anybody else ever had. Yes, sir?
Could you go back with the construction of the soundboard?
Construction of the sound. We're going to get to that. Okay? We'll be that in just a minute. I think it comes around, in fact, right after this, if I'm not mistaken. Okay, so the harp. Again, you saw the radial bracing. That's one of the things that are in there to help support against that 40,000 pounds of pressure that once you tune the piano. And then the cast iron harp, also bolted to the perimeter piano. That also is holding up against those pressures. So I've seen pianos where those actually crack and break. I had a friend of my father's was a tuner, and he used to go out and tune for, you know, a bunch of people, and he went to an old Erard. It's a very early piano. And the guy told him, yeah, tune it to 440. And the guy said, no, no, no. Yeah, he tuned the piano, and the plate disintegrated inside the piano. So it has to be made properly, it has to be done right, it has to be the right tensile strength, so on and so forth. These were built to what they called Bell quality cast iron. They're made out of cast iron. Yes, sir. Only in the aspect of two things. Those cupolas I mentioned. I'm sorry? Does the harp affect the sound of the piano? And again, only to the respect of that double cupola does give us those resonant chambers, so that helps, and the stability it offers. It holds, it keeps everything good and stable, so yes, to that point, yes. Does it add to tonal color and things like that? Yeah. Other than that double cupola, the cast iron in and of itself, probably not a lot. It's always been cast iron, yes. Yes. We used to actually have a foundry here in Queens. It was part of the factory. We made our own plates right here in Queens. The EPA and the DEC and all that eventually outlawed casting in the city, so we had to move that out. We still do own the foundry. We oversee it. It's down in Springfield, Ohio. We have people from our factory working in that foundry, and we keep a very close eye on what to do. Yes, ma'am? We'll try, because like I said, sometimes they kind of forget what they... Okay, stability. They are so stable. As I mentioned, we have pianos coming back here from grandma, and those are family heirlooms. They become part, and I have to tell you, these things actually sometimes become part of the family. They get names. You know, I'm not going to mention some of them, but they do get names. They literally become part of the family. We had a woman come in one time, and she asked us to restore her piano. And she had one condition. And that condition was that when she was about 6 years old, she was practicing a piece that she just couldn't get. She got so frustrated that she bent down and bit the piano. Really bit it. And she left. Teeth mark. Those teeth marks had to stay. Because when she did that, she broke free. It was the epiphany she needed, and she got the piece, and everything went great from there. So shortly right after that, we had a new vice president of manufacturing who came to visit restoration. And we had some pianos laid out for him to see, and he walked around, and he said, well, very nice, very nice. He says, but I got to tell you, I'm very disappointed. Oh, great, I got a new boss. He's disappointed already, first time at it. I said, yo, what's the matter? He goes, you guys, we finished the piano, and you couldn't even get the teeth marks out. So we had to bring him the folder and say, look, no, right here, in writing, teeth mark have to stay. What? Who would want the teeth mark? But that's how people get embroiled in these pianos. They literally, it becomes part of them, and part of their families. Okay, here we are at the soundboard. There are three components to the soundboard. The soundboard in and of itself, which is made up of planks of Sitka spruce glued together, ribs, which are underneath the soundboard, which help support what we call crown, and I'll explain a little bit about what crown is, and bridges. And like any other stringed instrument, a violin, a guitar, or any other instrument, strings pass over a bridge. Same in a piano. They pass over a bridge, and the strings hit that, and that's what translates the vibration into the soundboard. We have to select, and the gentleman on the left is selecting soundboard spruce. Before he even gets it, there are gentlemen who are out there, and they literally look at every single one of those planks. You'll notice that there's several planks there. There has to be a bare minimum of 10 grains per inch. And they literally sit there and count. They have a little thing that they put on there and say, okay, 1, 2, 3, 4, 5, 6. Has to be 10, every inch. They have to be what we call cortisone. They have to look at the edge of that piece of wood, and it can be no more than 30 degrees, the grain direction. And no grain line can fall off that plank. Think about what that means. A grain line in wood that you see, if it goes off that plank is no good. Because tone travels along those grain lines. And it'll fall off that board. It means it'll fall up. You'll lose tone. So every single one of them is checked like that. And we need a minimum of 10 in the bass section, but when we get into the treble, we want more because it's going to have a higher frequency, so we need more. So he's literally counting those grains, and if you'll notice, there's 2 lines. And what you barely can see over there is he's got them numbered. And what he's literally telling the guy who's going to make the panel is, this is exactly the way I want it laid out. I want number 1 here, 2, 3, 4, and I want them laid out in this orientation, so that the soundboard performs in the bass section the way we want it to, and in the treble section the way we want it to. So he's doing exactly that. Then it goes to a guy who puts it in a big jig, and he glues up the panels, and he moves it on to the next guy who assembles ribs. Now, I talked about bridges. These are the bridges here. He's working on the bridges. This guy has a bridge here, and he's doing what we call taking bearing. I think we'll hit that a little bit further. This gentleman that's a concert grand. And if you'll notice, see the way it looks kind of warped? It's kind of like in a curved section there. That's called crown. And we do that intentionally. And Steinway, New York, is the only one that does it this way. And what they do is they dry their soundboard panels, the planks, this piece right here, in a conditioning room. Now, remember I talked about conditioning and drying and things like that. They're going to get that down to 4.5% EMC, relative humidity. Ask any woodworker. That is next to impossible. I'm going to say impossible, next to it. It is so difficult to do that no other piano manufacturer will do it. The ribs, they're done to 8%, and we glue them together that way. And what happens? The soundboard absorbs some moisture. The ribs, because they were dried to a higher level, don't absorb as much moisture, so the board warps. And it builds what we call crown. Again, more tension. If you remember I said in the beginning, pianos like tension. They want to be tense. So by doing that, we've built tension into the board. Now they put the bridge on the top, and that helps to support that. Now what we did is we're now going to glue this soundboard in, and it's literally going to be in a dome like this. When we put the strings on, it's going to press down. 40,000 pounds trying to pull this way, but also 1,000 pounds of pressure straight down. So it's going to put 1,000 pounds of pressure on that bridge. And what happens is the bridge is pushing up, the strings are pushing down, and they do it to a point where the strings are literally, I love to say this, they're at their maximum state of excitability. I just like to do that. And they're at a position where when the hammer hits that string, it's ready to go off, and the soundboard is ready to pick up that vibration and send it out. So that is done very intentionally, and it works very, very well. And we are the only ones, it's extremely hard to do, and we are the only ones that do it that way. So this gentleman now has got his bridge on, and he's making, if you'll notice what he's got there, is a chisel. Nobody makes those chisels for us. Each one of these guys makes it themselves. They go out and find a piece of steel, and they put a handle on it, and they put the right angle on it, and they put the right cut on it. And when I first started, what used to happen is you would have to make your own chisels. There's 2 different chisels, and I'll show you. The next one is, okay, this is part of one other thing we missed. You see those circles? They mean something. What that is, see where it says diaphragmatic soundboard? Our soundboards are built thicker in the center and thinner at the edges. What that does is, where it's glued against the rim, it allows that soundboard, because it's thinner there, to vibrate more freely. And the weight in the center gives us inertia and lets the soundboard start to move. So again, between the crown, the diaphragmatic soundboard, again, Steinway's the only one that has that, and these grain counts is what gives us the responsiveness of our soundboards. So they're freer, more uniform vibration throughout the board, richer sound, more sound from a smaller piano. With those tensions and the way that soundboard moves, you can get, look, with pianos, there are no transistors, there's no amplifiers. We all know, the harder you play. But with piano, size is the only thing that matters. The bigger the piano, the more volume. But that said, if we can get more volume out of a smaller piano, why not, right? So those things allow that to happen. So by the time you get to the concert grand, here's a piano that without an amplifier, without a speaker, without anything else, you can hear it in the back of Carnegie Hall. So now we got to ribs. I'm going to go back. This gentleman here is performing an operation called taking bearing. Now you can't see it, but in here and along here, there are 7 little pieces of string. And they run them through where the normal strings would go, and they pass them over the bridge. Now, if that string passes over the bridge at too tight an angle, when you pull it up to pitch, it puts so much pressure on the soundboard that it literally what we call chokes it. It's got so much pressure down that the soundboard can't vibrate anymore. There's just too much pressure on it. If they pass it over at too slight an angle, there's no pressure, and it doesn't transfer the vibrations. So you get no volume, you get no carry. So that angle, called down bearing, is extremely, extremely important. And it's literally measured in 1/2 millimeter. And they've got to get that just right. And this gentleman, now he's got that. But we do that for there's 7 1/3 octaves in a piano. We put 7 strings in there. We do this for every single octave. So that's, literally that bridge could be slightly different heights at different areas, but it's done that way so that each octave has that same exactness of down bearing and gives us the same response. Back to the chisel. He literally made that chisel. What he's doing now, he's just setting up some of the notching, and you'll see that again in a minute. When I started, you used to have to make your own, before they allowed, this is called bellymen. These are the guys that work. We're not really sure if it's just because they're working in the belly of the piano, or they spend most of their day on their belly working in the piano. We don't know which one it is, but they both work. But you had to literally, to become a bellyman, the first thing you had to do was to make your tools. You literally had to make, back in those days, you used what they call a brace and bit. Now that's, before drills, you had to make one of those, you had to make it out of wood. So you had to make yourself a brace, and you had to show it to your foreman, and he would okay that. And then you had to make your chisels. And you'd literally make your chisel, and you'd sharpen it, and you'd carry it into him, and just like you'd see in the military, you hand your chisel to him, like you were handing your sword to your, back in the day, and he would take the chisel and he would look at it. Now, each one of them is very different because for each individual, they built it for their own hands. Some guys are right-handed, some guys are left-handed, whatever. You would make that chisel to be comfortable for yourself. So he would look at it and say, not look so much about the shape of it, but the quality of what you did. And then he would take that chisel and he would shake your hand. And then he would hold your hand out like this, and he would take that chisel and he would try to shave your arm. And if it wasn't sharp enough to shave the hairs off your arm, he gave it back to you and you went back and tried again. And until he could do that, and that was a badge of honor. You had a bald spot on the side of your arm. But that's how important some of these things are, and how some of these, they needed to see not only could you do the job, did you have the passion for the job? Did you have the passion to make those tools and get to where you needed to be? And if you did, then you were allowed to move on. Sorry? Not so much. We have machines that can sharpen the chisels, and they send the chisel to a machine shop, and they sharpen it for them. They're still as sharp. There still is, it's just that part of it. Quite frankly, if you grab the guy's arm now and tried to shave the hair off, and they'd probably arrest you. So, yeah, we don't, that's not done anymore, unfortunately. Now, the next component of the soundboard is ribs, and these are the things that go on the underside. You very rarely see them. If you got on the floor under the piano and looked up, you'd see them. And those are the things I told you, we condition to 8%, and that's what gives it. And if you notice, you can see that. You can see the warpage there. They're all bowed a little bit, and that's, again, done intentionally. And each one of them, once they're done, he drills a little hole into the bridge, and the guy dowels. Again, wooden dowels, not screws, not things like that. They're all hand doweled. And they're made of sugar pine, and the soundboard itself is made of spruce. And if I didn't mention it before, it's Sitka spruce. It comes from one place, Sitka, Alaska. And literally only on the north side of the mountain. And people, oh, sure. But it's true. The north side of the mountain gets less sun. The trees go slower. When they grow slower, the ring count gets closer. So we can get 11, 12 grains per inch on slow growth trees versus something that's sitting in the bright sun and growing very quickly. It's what they call very wide grain, not good for soundboards. This is, again, this is a gentleman that just recently retired, was one of the old tough guys, but he just recently retired. But that's soundboards with the ribs. Again, the ribs maintain the crown that we spoke about crown. Remember I told you that about the warping? Doesn't add a lot of weight because they're sugar pine, so it's a very light wood and allows the board to still vibrate. Longevity, again, it's holding that panel together because they go opposite the grain of the panels themselves. These go opposite, so it helps to keep that soundboard together and adds sound and power. Again, the longevity and projection of tone we spoke about. Bridges, that was the thing I told you about. Now, this is the third component of the soundboards, again, made of rock maple. Bearing is set by hand. We talked about bearing. And they plane the height. Again, for each individual octave, there are 7 different measurements that they take. Hand drilled, notched, and pinned. And that's extremely difficult. These are bridges. Now, if you can't see them, the bottom here is, you see all the little different laminations. And on this side, it has a cap. We put that cap on because that chisel that I spoke to you about, if you tried to chisel laminated wood, you'd get very uneven chiseling, and you'd get broken edges and things like that, very unattractive. So we put a maple cap on top of it so it gives these guys a nice smooth surface to notch. And what notching is that. And that's that chisel that I spoke to you about. That's the second chisel that you had to make. And what you see there, those little triangles here, that's string clearance. The strings, again, as I mentioned, have to pass over the bridge. So as they do that, they need clearance on either end to pass over that bridge. So that's what this gentleman is doing. Again, that, believe it or not, that may not look it, that is an extremely difficult operation to perform. And if you'll notice, the base bridge here this is the higher, that is the same height that that double cupola would be over the rest of the piano. Again, we do this, we laminate these laminations this way, not this way. If you laid them horizontally, when spring tension is added, they would still be able to bend, and they would go down. And if you orient them vertically like this, they are much stronger, and they transmit much more vibrating energy into the piano. And that cap helps to prevent them from cracking and splitting. When that happens, strings start to move, and tuning stability suffers. Now we're getting past the soundboard, we're into stringing. It's strung by hand. There is a small gadget here that helps to turn the string around the tuning pin. Believe it or not, we are not allowed no less and no more than 3 coils around every tuning pin. And somebody literally counts them at the end. And that, again, is for stability. It stops the pin from what we call flagpoling. So, and it's double checked all the time. The steel wires are different gauges. They're thinner in the treble, and they thicken up as you go towards the bass. And then eventually we have to start winding them with copper. And that gives you a more massive string to give you those bass notes. This is just a comment from one of our Steinway artists. And this is basically all the things you need for one single note to play on a piano. There are literally, for one single note, from the point where you touch the end of the key, which would be here, till this hammer hits the string, 57 parts for one key. You heard in the beginning 12,000 parts. Well, almost 6,000 of them are in the action. And all of those things have to work in concert in order for that action to perform properly and for you to get the proper feel. It's called an accelerated action. One of the things about an accelerated action is it has what we call a half-round bearing underneath the key. And what that does is it's part of a much bigger picture, but it allows the key to be depressed easy with less force and tension than a conventional action. And they actually play about 15% faster than a standard action. But they're hand balanced, hand bush. You'll see what this operation here is, these little things here are weights. For every gram of weight you put on a hammer, you feel 7 grams of weight at the thing. So that can add up quite a bit, quite quickly. So in order to counterbalance all those action parts, we put weights into the keys to help them work. Now, as before it said, you'll see it says here, hand balanced, bushed, and assembled, and some of the different materials that it's made of. Well, bushing is this little thing right there, that little red thing. There's one there, one here that you don't see, and another one here. Each one of those is installed by hand. There are people literally threading that with a little thread and needle, pulling them through each one of those action parts. 88 action parts. There's 1, 2, 3, 4, 5, 6 of them in each key, times 88, and we'll make about 10 actions a day. So there are people stringing every single one of those bushings by hand. I lost the count of the math, but it's a considerable amount of work, and they're doing all of that. And all of these are assembled by hand. By the way, these action parts are made right here in New York and Queens. We are the only piano manufacturer in the United States that makes their own action parts. Everybody else buys them from somewhere else, but we make them right here in New York. And we make what are considered the best hammers in the world. Now, one of the other things here says hand-assembled and regulated. Regulating means every single one of those parts have 5 to 6 adjustments, just physical adjustments. And then there is a whole bunch of things that you have to do to the wood to make it fit where it needs to be. So regulation means that. And these are guys that are doing different aspects of the regulation. And it's really, really, really hard to see. I was hoping to be able to see it better, but this guy right here, they use a flame. And what they do is, when we glue hammers together, they sometimes are like this in the piano, but they all need to be like soldiers. And what they do is they heat up the wood. And when the wood reaches a certain temperature, it starts to develop steam, and the wood just kind of lets go, and you'll see it, the hammer boom back. Well, next morning, guess what? It's halfway back to where it was before. So they do it again. And next morning, it's halfway back to that, until we finally get it to say, okay, I'm staying. But they go over and over and over this. It's done actually 4 different times before it leaves the factory. And part of that is the stability, reliability, again, the speed of the accelerated action, and less service. They're sturdy enough that they need less service than a standard action. One of the things, real quickly, here, you'll see these 4 little kind of ears on these parts. That's a rosette-shaped dowel. On most pianos, almost every other one I do know of, they're either aluminum or wood. And it's a flat surface, and it allows those parts to shift a little bit. When you put those parts on here, they have a matching profile on the parts that lock it in solid, so they don't move. And that less service, that's part of it. Because those parts don't move, you have to call somebody in to adjust them less often. Okay, now we're into finish. One of the final aspects of the piano. Now, we have 2 finishes here now in New York. One is the old traditional lacquer. Now, I grew up with lacquer, so that's my favorite. But we made lacquer pianos for, well, back in the 40s, they switched from varnish. There was a big transition in New York. There were varnishes unions back then, and everything was done in varnish. Lacquer was like a miracle. It dried fast. You could rub it and polish it. It was easy to use, less flammable, things like that. So we went to lacquer in the 40s, and we've been using it ever since. Our wood pianos, still we use lacquer on those. But today, Asia, Europe, a lot of the younger people coming up want this shiny, fancy looking, so we've gone to polyester, which is what you see here. High gloss finish, tough as nails, impervious to almost everything. Perfume, alcohol, you name it, it's impervious to it. Lacquer, on the other hand, took a lot of maintenance, and you had to be very careful with it. So the 2 finishes that we have were nitrocellulose lacquer or the paraffinated polyester. Lacquer is hand rubbed. Literally, guys go out, and I'll show you a couple. This is, by the way, spraying polyester up on top. Those guys have to wear special suits. It's a very, it's not a dangerous material, but once it sticks on you, it's like glue, and you can't get it off. Lacquer is a little bit different, and the guy on the bottom is spraying lacquer. This in the back here, that's an oil bath, an oil waterfall. It catches overspray. Lacquer tends to be a little bit more less friendly to the environment, so we have to do special things to make sure that we don't get it out there, and that picks up what we call overspray. You see, that's overspray. That's stuff that doesn't go on the piano, so we don't want that going out. When you spray perfectly, 30% of what you spray goes out. And when you make mistakes like that, it's a lot more. So we don't want it in the environment, so we catch it there. At the end of the year, we run a centrifuge through it. We get all those particles out, and we reuse the oil so we don't pollute with the oil, and the material gets incinerated. Now, this is the polyester. The guy on the left is sanding polyester. You'll see it's very dull at that point, but then we take it over to this side of the room and we polish it up with buffing wheels, same like you would do on an automobile. Lacquer, on the other hand, he's got, it's called rubbing solution. This is one of the jobs my father did when he first started, and he's literally putting those ribbon lines that would affect something like the piano on the other side would have, putting those lines into it on a rough basis, and then by hand polishing. By the way, that is a concert grand in what we call Kewazinga Bubinga. That's an African rosewood. I think I've only seen 2 of them in my entire life. So it's a very rare piano. Yes. Sorry, somebody had a question?
What is the difference between hand polished and hand rubbed?
This is polished. This when you reach this, that's polished. Hand rubbed, and quite frankly, polishing. Okay, hand rubbing is rough. Hand polishing is fine. Rubbing is first. Polishing is second. I started as a rubber. I became, and believe me, when I was in school, my father was a rubber, and when they would go around the room and they'd say, "Well, what does your father do?" My father's a cop. My father's and they'd come to me and they go, "Nah." No, really. Well, my father's a rubber. His father's rubber. Didn't go well. So I always thought my father was a finisher. But so yeah, rubbing is the very rough. It's the very early stages. When you spray, it gets something called orange peel, and it's called that because it looks like the skin of an orange. It's very bumpy and very kind. You want to smooth it out. The first operation is rubbing, gets rid of the orange peel. Polishing then brings it up to whatever shine level you're trying to attain. It could be anywhere from that ribbon Steinway, old ribbon effect to high polish. But rubbing is the initial step, and then polishing. The reason for the finish, it obviously protects and enhances the grain and the depth of color and protects the piano in and of itself. But if you take a piece of wood and it's raw and you look at it, it can be attractive, but add lacquer or polyester and it brings out all of the depth and color in that wood. So one of the reasons why we have to use it. Okay, we are at the point now where all of those things have made a piano that since 1985, the piano is now appreciated 2.1 times. And 50-year-old piano, 9 times what you paid for it. So we know that building the pianos the way we build them is the way to do it because they actually appreciate in value over time. This is one of my favorite. The whole is more than the sum of its parts, and literally it is that, because each one of those parts in and of itself is very impressive. And everything I talked about tonight, maybe you could tell, you might not, I'm impressed with all of it. I think it's quite fantastic the way these things work together and how they come out, and it's an engineering marvel. Even to this day, when they were invented, they were considered an engineering marvel. And today I still look at it that way. Are there more technologically advanced? Absolutely. But to make all of these things, all these different materials, all of that work together to come up with such gorgeous music and such a beautiful sound, to me it just, I never get tired of it. So yeah, the actual whole of this thing is worth way, way, way more than each of the individual parts. Okay. Thank you. Thank you very much. Thank you. Yes.
Before we get to the Q&A, just wanted to let you know that we are recording, so please wait until the wireless microphone comes to you before asking your question. Thank you very much.
Okay, we have a young lady over here.
Do you play?
Not a note. If you held a gun to my head, I couldn't play chopsticks. I apologize. I'm sorry. And I'll tell you what I tell everybody else that asks me that. I spent so much time trying to learn how to make these things right. I didn't have time. Does that work? I tried it. No, when I was growing up, it was all about electric guitars. you know, the Beatles had come to, you know, America, and it was, you know, electric, so I learned how to play an electric guitar. My sister learned piano, but I was like, piano, no, I'm gonna be one of those guys up there where all the girls are chasing. I want to play an electric guitar. So no, unfortunately, I don't. This young lady here, shoes.
Does Steinway make their own strings? And if not, where do you source them?
We did for a very long period of time. And I'll tell you a quick story. There was a guy by the name of Teddy Matweegee. He was a friend of my grandfather's, and he used to make the piano strings. We decided at one point that technology actually made a slightly better string, so we stopped making them. And he retired 2 years later, and in between he had a really bad accident, so he kind of like, you know, one of those things that you always remember. But we buy them from a company by the name of Mapes. Now, I was telling somebody earlier today, my grandfather was a blind tuner. He learned how to tune at the lighthouse. And my father used to drive him to work. We lived in the Bronx. And he used to drive him over to Triborough Bridge to work and then go back. And he worked at Mapes piano strings in the Bronx. Mapes has since moved to Tennessee. But we get our bass strings from Mapes, and so does Hamburg. They use Mapes piano strings as well. So yeah, we get them from a company by the name of Mapes.
When Steinway started in the 1850s, the piano was less than 100 years old, I guess.
Well, the piano was originally invented in the 1600s, so it wasn't quite the piano it is today, but a guy by the name of Bartolomeo Cristofori invented the piano in the late 1600s.
All right, I stand corrected, but I know it was still being developed in Beethoven's time.
Yep.
And of course, now you've got a lot of consistency in terms of how these things are made, and obviously there are going to be some changes at certain times. You talked about going from the varnish to the lacquer. Mm-hmm. Obviously, you can't get ivory keys anymore. But I assume that things have pretty much settled down and you've figured out the way that you're going to make these things.
Yeah.
But there must have been a lot of development early on, you know, figuring out which kinds of woods to use in the areas, coming up with the double bridge
the double cupola.
The double cupola. And also, I assume that they did not have access to Alaskan Sitka spruce at that time either. Alaska wasn't even part of the U.S. So is there a certain time when that experimentation and development settled down and it sort of became the consistent model that it is now?
Yeah, I would say by the time you reach the 1900s, early 19 teens, it started to settle down, but it's picking up again. It never kind of sat on our laurels. The action, small improvements were made to speed up the action, geometry changes, what we call scaling changes. Basically the schedule on which the strings are laid out and the shape of that stuff was ongoing. The big changes, the big improvements had pretty much slowed down a little bit. But now we're getting into we have a new player piano, so that's new technology and things like that called the Spirio. Super impressive. Quite frankly, look, I'm an old timer. As much as I hate to say it, I'm an old timer at Steinway, but. And I was a purist. When I first heard we were going to get into the player biz, I was like, oh my God, what are we doing? The thing is amazing. It's absolutely amazing. So, yeah, it slowed down for quite a while, but I think it's starting to pick up again with some of the improvements going into the piano. Yes, ma'am. I'm sorry.
You actually mentioned Hamburg a few minutes ago. Do you still make pianos in Germany, and what is different about that process or in that location?
We do still build pianos in Hamburg. One of the brothers went back, I think it was 25 or 26 years after we started here in New York, so it's a New York company, but we do still build them in Hamburg. They went to polyester a long time ago. Europe was looking for that high polished look. Quite frankly, what they're telling us, we tried to bring some of the satin New York pianos into Europe, and they told us that they felt that by satinizing, we were trying to hide something. So they were used to that high polish. So they went to polyester a lot sooner. With polyester, there has to be certain changes to the architecture of the piano. Polyester does not like inside corners. Hates inside corners. So they had to try to eliminate sharp corners, inside corners, things like that. So the architecture of the piano case itself changed somewhat. They did some changes to how they produce the soundboard, and they don't make their own actions. They buy their actions from a company by the name of Renner. Very, very good action manufacturer. All they do. My personal opinion is the New York action's better, but I'm prejudiced. But yeah, they are slightly different, but quite frankly, now that we're doing polyester, I would say within 5 years, you probably couldn't tell the difference between the two pianos looking at them. So we're converging. There was a period in time where New York and Hamburg didn't even talk. I mean, there were years before we even had a conversation back and forth. During the war, it got real difficult, as you can imagine. Yeah, we now have a presence from New York. Matter of fact, there are 4 guys from New York going to Hamburg next week. They'll spend a month there, teaching them how we do things, picking up some of the things that they do. And what we're in the middle of right now is what they call a continuous improvement program, where we're going to take the best of both and incorporate them into either or, and literally come up with a unified kind of best piano.
What is the difference between the Steinway, the Essex, and the Boston?
Big difference. Steinway is made here in New York, obviously, by hand. What we did with Boston and Essex was to take advantage of, look, Steinway pianos are not for everybody. They are very expensive. We needed pianos that entry-level people, and we wanted a quality piano to get away from some of these other Asian imports and things like that. The difference and the strong point about those two pianos is that they are completely designed by Steinway. What most people do, you can go to Asia now and basically buy, I think Chickering is made over there now, some of the old Kanabi, some of the old names are made over in Asia. What they did was they went over and they said, oh, okay, that's a nice piano. Put my name on it and give me 1,000 of them. Steinway didn't do that. We went over there and we said, okay, we see how you build pianos. This is what we want. We want this in the piano. We want that in the piano. We actually own all the jigs and fixtures in those factories that produce the Boston and Essex. They are not allowed to use any of the technology. They're not allowed to use any of the technology that we've given them. But all of the things that go into those pianos were designed by us, engineered by us, and dictated by us as to how they're being built. So we took advantage of their mechanisms, quite frankly, the cheaper labor, and their distribution. And we said, okay, we're going to take advantage of that, but this is what we want built. So they are very different pianos. One's built in Japan, and the other one in China. Essex is in China, and Boston is in Japan. Boston is a better piano than the Essex, and the Essex is a better piano than most of the other Asian pianos that you can get your hands on. But that is the difference. And what we basically said when we did this was, I was promised back then, we'll never see a Boston and Essex in the New York factory, because you can't tell a Steinway worker or a quality worker to work at a lesser quality level. You just can't do it. It's not possible to do. So we just took advantage of their manufacturing capabilities, their mechanization, and we used that to come up with a slightly less expensive piano but again, that we have what they call the Steinway promise. If you buy an Essex today and you decide 5 years from now you want a Steinway, they'll give you 100% of what you paid for that Essex towards a Steinway. So they're part of the Steinway family of products, but very, very different from the Steinway build.
Last question.
Forgive me, Mr. Wood. The case,
Yes.
those laminations, do you create your own laminations?
Yes.
And what moisture content is that wood?
Almost everything that we use other than the soundboard is at about 6%. So it's a very low moisture content. But in order for me to make a 9-foot concert grand, I need 28 feet of laminations. To find 28 feet of perfectly good wood nowadays, even back then, is next to impossible. So we literally have to defect. You saw the guy selecting? What he's doing, he's looking for defects, and he's going to cut out those defects, and then we finger joint them together. The thing with that is, when we bend them around that press, they are oriented so that none of those finger joints are at a tight bend. They're all on straight areas, so we don't put extra tension on them. But in order to get the widths and lengths that we need, we literally have to make them up that way.
And what glues do you use?
The rim laminations are what they call a urea formaldehyde glue. It's a little bit nasty, but it's waterproof. It's very, very tight glue. And like I said, big key there, waterproof. Because back in the old days, they used hot hide animal glue. You know, when they used to send the horse to the glue factory, what used to come out of there was hot hide animal glue. And that stuff in high humidity and water would just loosen up. So these glues are much more...
When did they make that change?
I'd be lying to tell you I knew exact date. It's a considerable amount of time. I'm sorry, I wish I had it. If you'd like, I will try to find that out for you, and we can get in touch with you and let you know. Can we have one more? We just have one more person here? I'm sorry?
We're going to address that. We are going to address that in a minute. If you would just hold on, sir. Thank you. Bill, that was outstanding. And if I can quote your own words back at you, the Steinway piano is an engineering marvel. It is a perfect fusion of art, engineering, and architecture. And your enthusiasm that you so vividly conveyed, I feel like we've gone through the 12,000 pieces. It was really wonderful, and we are honored to have you represent Steinway. So thank you so much, Bill. Thank you. And as I mentioned, I'm going to ask Jennifer and Dan to come up and join us, and they are going to tell you a little bit more about Steinway. But before we do that, Victoria Dengel, our executive director, is going to make a presentation to Bill.
Thank you. And Bill, thank you, Karen. And I'd like to add to Karen's remarks and say, as an organization founded by 22 craftsmen 233 years ago, you're a veritable celebrity in our midst. So thank you. Thank you so much. And your lecture was beautiful. And I just have to look at that piano now and say that, you spoke about the soul of a piano, and I will never look at another piano or be at another concert and not see the soul of all of those craftsmen who construct the piano. Thank you. Thank you. So, on behalf of the General Society of Mechanics and Tradesmen, founded 1785, we express our gratitude to Bill Youse, Director of Technical Services and Special Projects at Steinway Sons, for his Steinway pianos, third-generation Steinway craftsman, and to be so enthusiastic 45 years into the job. Wow. For his participation in the General Society Artisan Lecture Series. Thank you so much, Bill. Thank you. Thank you. Thank you.
Thank you very much.
And Bill, because we've gotten to like you already, we have made you a lifetime member of our library. So please come back.
Thank you so much.
Yes. Thank you. Thank you. Thank you.
If you contact the Queens Historical Society, every Tuesday they give a tour of the factory. So if you contact them, they will arrange to have you, if you can get together with them, they'll give you a tour of the factory.
Right, yes. And I'm now going to invite Jennifer Chiaramonte and Dan Miceli to join us, who I said have been literally instrumental in this evening. And I also want to thank Rella Fogliano, who made the introduction in the first instance. So, Jennifer, you'd like to say a few words.
Thank you. Thank you, Karen, Victoria, and Bill, thank you so much for being here. My name is Jennifer Sharamonti. I'm a sales representative at Steinway Sons, and I've been with this wonderful company for 13 years, so not even a fraction of how long Bill has, but I'm very, very proud to be with Steinway Sons. I'm also a piano teacher and a pianist, so my whole life has revolved around these beautiful pianos, and I have one at home, so I love what I do. But if anyone has any questions about, you have further questions that we didn't get to, I'll be up here with a few brochures and my cards. So we're just around the block at 43rd Street. So we were on 57th Street for 89 years. Maybe many of you have been there. But since 2016, we've made our new home at 43rd and 6th, right on the corner, and we're very happy, and the pianos are very happy there. So if anyone has any questions, tours, I'm happy to speak with you a little bit more about that. We have a special VIP selection experience and tour that's coming up in the next week or so. So also, I'd like to also introduce to you Dan Miceli, the Director of Sales at Steinway Hall.
Thank you, Jennifer. There's not much to say. You've heard it all. Except we do invite you around the corner. We are neighbors, and that's why we're here. And even though we're neighbors, we still had to use a delivery truck to deliver this. So we'll get this playing, and you can hear our newest technology, as Bill noticed. And thank you, everyone, for coming this evening.
Thank you. Thank you. Bill, so many thanks again, really. Absolutely fantastic. Oh, a fantastic presentation. Thank you all for coming. I hope you will now join us for a glass of wine. And as Jennifer just said, there's plenty of opportunity to ask more questions. So thank you so much. Good night.